Hey everyone, and welcome back to Cursor.mp4. Today we're diving into something that is, frankly, one of the most important concepts in AI right now. It's called Retrieval-Augmented Generation, or RAG. And trust me, it's the secret sauce that makes AI actually, smart and reliable.
Okay, let's just get right into it. We've all seen these large language models do some incredible things, right? It feels almost like magic sometimes. But, and it's a big but, if you've ever tried to use them for something really serious, you've probably run into some major walls. Turns out, they have a couple of really fundamental weaknesses that can be total deal breakers. So, problem number one, their knowledge is totally stuck in the past. I mean, a model trained in 2023 has literally no clue what happened yesterday. That makes it pretty much useless for anything that needs up-to-date info. And then there's the second, even bigger problem. They hallucinate, which, let's be honest, is just a nice way of saying they lie with incredible confidence. And that's a massive issue if you're trying to build, an application that people can actually trust.
So how do we fix this mess? Well, that is exactly where RAG comes into the picture. And the core idea here is it's just brilliantly simple. It's like giving your LLM an open book exam instead of a closed book one.
Right, so think about it like this. Instead of a closed book test where the AI has to rely only on what it's memorized, RAG gives it an open book exam. It hooks the LLM up to an external, totally dynamic knowledge source. This means it can actually look up the relevant information before it generates a response. It's a total game changer.
Okay, so how does it actually work? Well, it's this super simple but really powerful four-step process. First, you ask a question. That's the query. But instead of just guessing, the system goes and retrieves relevant documents from that external knowledge base we just talked about. Then, and this is the magic part, it augments your original prompt with all that new info. And only then does the LLM generate the answer using this new, much richer context. It's this whole cycle: query, retrieve, augment, generate. That's what makes modern AI so much more powerful and, frankly, trustworthy.
All right, so we're giving the AI a library. Cool. But here's the thing. How you organize that library, well, that changes everything. The way you structure that external knowledge base completely dictates what your AI can and can't do.
Basically, you've got two main ways to go about this. First, you have vector R-age. The best way to think about this is like a librarian finding books that have this same general vibe. It's all about semantic meaning. It's super fast, great for unstructured text. Then you've got GraphR. This is totally different. It's more like a detective or a researcher following a web of clues or citations. It's all about finding the explicit connections between things, which is incredibly powerful for complex reasoning.
And this chart really lays out the trade-offs, right? With vector RAG, you're dealing with vector embeddings of text chunks. It's a fast, kind of plug-and-play setup, great for your standard chatbots, FAQs, that sort of thing. But graph RAG, well, it's building a whole knowledge graph with nodes and edges. It's slower to set up, for sure, because you have to design a schema, but the payoff is huge. You get this incredible multi-hop relational reasoning. We're talking about stuff like medical diagnosis or deep legal research, where understanding the connections is everything.
Okay, so basic RAG is already super powerful, but this is AI we're talking about. The whole ecosystem is evolving at like light speed. So let's look at some of the more advanced RAG architectures that are popping up. First, there's this idea of modular RAG. And the quote here says it all. It's about transforming RAG into these Lego-like reconfigurable frameworks. I mean, how cool is that? You can literally just swap out different parts, your retriever, maybe you add a re-ranker, a different generator, and build the perfect system for whatever you're trying to do.
Then you have self-RAG, and this is where things get really wild. The idea here is an AI that learns to retrieve, generate, and critique through self-reflection. So it's an AI that's actually smart enough to know when it doesn't know something and needs to go look it up. It can even critique its own answers. It's like having a tiny built-in fact-checker, which is just wow.
Okay, I know this diagram looks a little intense, but it shows a really brilliant system called long RAG. So here's the problem it solves. When you feed an AI a really, really long document, it kind of gets lost in the middle. It might forget what was at the beginning by the time it reaches the end. Long RAG fixes this with a clever dual perspective approach. It's almost like it reads the document twice at the same time, once to get the big picture summary and once to zero in on the nitty-gritty details. It then combines both, making sure it doesn't miss the forest or the trees. Pretty smart, right?
So, this all sounds great in theory, but what do engineers actually do? What does a RAG system look like when it's out in the real world, in production? We're going to get into that. And hey, speaking of which, if you're getting some value out of this deep dive, do me a favor and hit that like and subscribe button. It seriously helps us keep making more explainers like this one.
Right. Here's the big secret of production systems. It is not vector versus keyword search. It's both. You always use both. This is called hybrid search, and it's pretty much the industry standard for a very, very good reason. Think of it like fishing. A really solid, production-ready system uses vector search to cast this huge, wide net to pull in everything that's semantically related. But then it uses keyword search, like a spear, to catch those very specific terms, exact product names, error codes, things that have to be precise. And once you've got all that, you're not done. You then run it all through filtering and re-ranking to make sure only the absolute best, most relevant results actually get passed on to the LLM. And a really critical piece of that quality control is what's called threshold filtering. It sounds complicated, but it's not. The system scores how relevant each retrieved document is, usually with something called cosine similarity, which is just a mathy way of saying how close is the vibe. If the score is too low, like you see on the chart here, maybe below 0.7, the system just throws it away. Garbage in, garbage out, right? This is all about preventing noise from confusing the LLM.
Okay, so where is all this going? What's the future of RAG? Well, the thing to understand is that RAG isn't just another technique. It's a really fundamental shift in how we're thinking about building AI systems, grounding them in, well, reality.
At the end of the day, here's the big takeaway. RAG is this incredibly flexible and powerful framework for tying these amazing, creative LLMs to verifiable facts. It's what makes some safer, way more accurate, and honestly, something we can actually begin to trust.
And that leaves us with a pretty wild question to chew on, right? If an AI can access and reason over all of human knowledge in an instant, what does it even mean to be an expert anymore? It really makes you think. I'd love to know what you think, so drop a comment down below. And hey, don't forget to subscribe for more deep dives like this one. Thanks for watching.